In this lecture video, we will learn how to name small molecular compound systematically using IUPAC guidelines. So again, IUPAC established different guidelines to name different types of chemical substances. Depending on the different types of chemical substance, we will then use certain guidelines to name them. So thus, it's important that we first identify what is a molecular compound. Now, molecular compounds are basically molecules or substances that consist of two or more different non-metals in them. So let's write that out. Consists of two or more different non-metals. Most molecular compounds tend to be really big, meaning they consist of a lot of different atoms. For example, 10 atoms, 20 atoms, 100 atoms. These are actually very common. But here in our class, we will first learn to name very small molecular compounds, and more specifically, those that consist of two different types of non-metal in them. So that would be our emphasis. For molecules that consist of two or more different non-metal in them, a lot of time, these are organic substances. And we will learn how to name this later by using different guidelines for organic compound. So here is IUPAC guidelines how to name small molecular compound, those that consist of two different non-metal in them. First, we name the element that appear first on the chemical formula that we see. And we also include the prefix to indicate how many of the first element that we see in the chemical formula. We will then name the second element with the ending of the second element changed to IDE. And again, we also include the number prefix to indicate how many of the second element that we would have. And the number prefix are as follows. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So these are the number prefixes, and it will be wise to memorize these number prefixes because we will be using these number prefixes very often. Let's now try a few examples. Si2Cl6. How would we name this molecular compound? Now first, we know this is a molecular compound because silicon and chlorine are both non-metal. And in this molecule, in this example, silicon is being listed first, and there's two of it. So therefore, we have to name the silicon first. And since there are two silicon, it will then be disilicon, followed by a space. And the second element is the chlorine, and we have 6 of it. And in this case, we have to change the ending of the second element into IDE. So therefore, chlorine become chloride. So in this case, hexachloride. So that's how we would be naming this molecule. Let's now try another example. SiCl4. How will we name these molecules? So here in this case, silicon is first, and we have 1 of it. So therefore, monosilicon, followed by a space. And now there are 4 chlorine. So therefore, tetra for 4. And again, chlorine become chloride. So tetrachloride. So that would be the name of this molecule. Now, anytime that the beginning of the name start with the prefix mono, it is usually being omitted because it's showing information they're not that necessary. So here in this case, this can be further simplified to simply silicon, followed by tetrachloride. So therefore, whenever we are listing something without the prefix, we would know that there will be 1 of it. So in this case, the mono is omitted again. So another small guideline from IUPAC. The A and the O from the number prefixes are usually omitted if the next letter is above. because we see above that many of the number prefixes have A and O in them. And a lot of time, this A and this O right here are being omitted to make it easier to pronounce the name. For an example, let's say if O5 is part of the name of a molecular compound, rather than naming this as pentaoxide, it is simply thus pentoxide. So again, the A is omitted, followed by the oxide. So pentoxide rather than pentaoxide. So in this case, we see that the A is being omitted because the next letter of the name is an O. Another example, N2O4, the name of this molecule will then be dinitrogen, and there are 4 oxygen, so that will be tetraoxide, and again, the A from the tetra will be omitted, so this becomes tetroxide. And N2O3 would be named as dinitrogen trioxide. So we do not do anything to the I and only omitting the A and the O. And lastly, H2O. How would we name H2O systematically? So in this case, there are 2 hydrogen, so therefore dihydrogen. And now we have 1 oxygen, so we have to include mono. And monoxide. So in this case right here, the O, this O will be omitted right here. So therefore it becomes monoxide rather than monoxide. So that's how we would name water systematically. Now, certain molecular compounds are being used on a daily basis. And if we were to have to name them systematically all of the time, they get complicated and therefore not useful. So therefore, for molecular compound that we use on a regular basis, we give them common name. For example, H2O is named as water rather than dihydrogen monoxide. Imagine going to a restaurant and order a glass of dihydrogen monoxide. That gets pretty complicated, right? So therefore, IUPAC also accept some of the common name for commonly used molecular compound. Another one that we also use quite often will be hydrogen peroxide. So H2O2 is hydrogen peroxide, NH3 is ammonia, and maybe CH4 is methane. So these are 4 of the very common ones that we use, and it will be good for us to remember these common names.